Hi, this is Mrs. Pope from Roger Bacon High School, and today we're going to be talking about solving radical equations and inequalities. This is section 6.7 in your books, and I'm going to start off with an example about hang time. This fits nicely since there's a basketball game tonight. When you jump, the time that you're in the air is your hang time, and hang time can be calculated in seconds, t, those are the seconds, if you know the height of the jump in feet. So, just so you know, in case you were wondering and you wanted to calculate your hanging time, well, it would be equal to half of the square root of the height that you jump. So your hang time t can be calculated by, where's my half? 0.5, I said it and didn't write it. Half of the square root of the height that you jump, as long as your jump is recorded in feet. So Michael Jordan had a hang time of about 98 seconds. How would you calculate the height of his jump? These are the types of questions we're going to be able to answer once we start solving radical equations. And we'll come back to this, and maybe, just maybe, if we have time, we can calculate some of our own hang time during class. But no guarantees, just depends on how we get through all this. All right, before we begin, I have a couple of vocab words that I think are important. Radical equation. And that includes anything that includes a radical expression. So if you have a radical sign in it, it's a radical equation, and an equal sign, of course. Extraneous solutions. This is a solution that does not satisfy the original equation. And we'll talk about that. She'll be solving some of them, and then when you get finished, if you go and check it and put it back in the equation, it doesn't work. So it would be like an imaginary solution, something like that, where it makes sense mathematically or algebraically, but when you plug it in, it doesn't actually work when you check it out. Okay, let's look at some examples. Scoot up a little bit. Not that far. No. All right, example 1, the types of problems we're going to be solving. You would see something like this. It would say solve square root of x plus 2 plus 4 is equal to 7. And we're trying to get that x. So we got to get it out of the radical and get it all by itself. So for this first example, I'll write steps. The other ones I won't. You can refer back here if you would like to. Step 1 is to isolate the radical. So if I were doing that with the example I have, here's my original problem. Trying to isolate the radical, get it by itself. Well, first thing I'll need to do is move that 4. So then I have square root x plus 2 is equal to 3. So I've isolated the radical. The radical doesn't have a coefficient, nothing multiplied in front of it, and it doesn't have anything added or subtracted. It's just the radical here and the radicand inside. So step 2 is to square both sides. Now here, notice I said square. The only reason I'm squaring is because I have a square root. If you had a cube root, you would cube both sides. If you had a fourth root, you would take the fourth power of each side. So you do whatever undoes, that's definitely not a word, whatever undoes the radical. So here, I actually want to square both sides. So let's take a blue. I'm going to square both of these. And the reason I did that, if you take the square root of something and square it, it goes away. And then I would be left with x plus 2 is equal to 9, or x is equal to 7. And this would be my answer. Let me not say my final answer. because this last step is to check. So, well, I didn't write down step 3 was solve for x. Then step 4 would be check an original equation. Let's see if it works. Square root of, let's put in 7. I'm checking it back here in the original equation and see if it comes true. So, square root of 7 plus 2 plus 4, does that equal 7? Well, let's see. 7 plus 2 would be 9. Square root of 9 would be 3. 3 plus 4, hot dog, it's going to work out. 7 is equal to 7, so it works. Check. Make sure you always check it. It's not always going to work. I'm not saying the way we did it is not always going to work. The solution may be extraneous. All right, example 2. You would see something like square root of x minus 12 is equal to 2 minus square root of x. All right. Step 1, isolate the radical. Well, we have a radical here and a radical over here. So this one here is by itself. This one's not by itself, but you can consider this a binomial. Just think, if I move the 2 over there, then this wouldn't be by itself. So just consider it a binomial, and let's square both sides. Now if I square the left side, that one we've already done one like this, it just comes out to x minus 12. Over here, remember, this means 2 minus radical x times 2 minus radical x. Don't go being lazy and putting 4 minus x. Not going to work. So you need to FOIL this, right? So we would have the first 2 times 2, 4, minus 2 radical x inside, minus 2 radical x, last, plus x. So I have x plus 12 is equal to 4 minus, combine our like terms, 4 radical x plus x. That's getting worse and worse. Okay, so let's get all of our x's on one side. I'm going to subtract x from both sides. And that goes away. I'm left with 12 is equal to 4 minus 4 radical x. And remember, I'm trying to get x by itself. So what can we do? Let's subtract 4 from both sides. Then we have 8 is equal to negative 4 radical x. Divide by negative 4. And now we're going to square both sides. All right. Ooh, okay, this is so much fun. Some of you probably already caught it. I made a huge mistake. This is great. I'm going to give you a second, pause the video, and see if you can see in here where I made a big mistake. Take a moment. Okay, you should be back. Did anybody find it? I'm sure you did. If you didn't, then let me show you. I don't know what the heck I was doing. Notice here, I have my equation. It was x minus 12. Some reason, I just turned that to a plus 12. No clue why. So that's not right. This should have been a negative 12 all the way down. So let's change it. Let's fix it. And you should be writing in pencil anyway. I mean, unless you're a shooter and you have a pen, then you should be able to correct this. Otherwise, scratch it out and start over. So let's turn that to negative 12. And then if I take negative 12 minus 4, I'm not going to get negative 8 here. See how easy it is to erase pencil? This is not really a pencil. I should have had negative 16, right? And then when I divided by negative 4, I would have ended up with positive 4 instead of negative 2. Then when I would have squared my 4, I would have ended up with 16. So the answer would have been 16. Now let's check our answer and see even if that answer, we know it's right here, but let's see if it's a real solution. So if I put 16 minus 12 is equal to 2 minus square root of 16. Does that work? And we're checking. So is this true? Well, square root of 4, is that equal to 2 minus 4? Ew, not looking good. 2 does not equal negative 2, because I would have had 2 minus 4, which would have been negative 2. So this is an extraneous solution. All right, moving on. Here's example 3. We have a cubic one, so 3n plus 2 to the power of 1/3 plus 1 is equal to 0. We need to solve this. So, first things first, I have to the 1/3 power, which means the cube root. If I were to get rid of this, I would need to raise it to the 3rd power. You see that? I'm going to raise it to the 3rd power. So first, remember I want to isolate my radical. So I can bring it down. 3n plus 2 to the 1/3 raised to the 3rd power equals negative 1. And I also have to raise that to the 3rd power. These two are going to cancel out, and I'll be left with 3n plus 2 is equal to negative 1. And then if you solve, go ahead and solve for n, you can do that. You would end up with n is equal to negative 1. You go ahead and check that on your own and see if you get an extraneous solution or not. All right? Now, I have a couple for you to try, or one for you to try. Try 3 times 5y minus 1 to the power of 1/3 minus 2 equals 0. Try that on your own and come back when you're done. All right, you should be finished by now. I'll check your work tomorrow, but I hope, just think about it, don't forget to divide by that 3 on the outside if you were still working on it. Okay, here we go. Example 4. I'm going to set this one up for you and let you finish it. So, if you have square root 7a minus 2, that's all under the radical, is equal to the square root of a plus 3, how do you think we'd solve that? Here's my hint. Square both sides. So you're going to square both sides. That'll get rid of the radical. I want you to finish that one on your own as well. All right. The last type that we're going to talk about today, we're going to be solving radical inequalities. So you'd see an example like this. Solve square root of 2x plus 2 plus 1 is greater than or equal to 5. And the first step that you have to do is, if it's an even root, like square or fourth, so if the index is even, find possible values for the radicand. Sorry, I'm not going to make it under 15 minutes. Sorry, Tabitha, I lied. All right, here we go. So square root of 2x plus 2 plus 1 greater than or equal to 5. I'll try to hurry. We're going to subtract 1 from both sides. So square root of 2x plus 2 is greater than or equal to 4. Now, before we get started, step 1, if the index is even, so this is a square root, before I even look at any values, I need to make sure that what's on the inside is positive. So the first thing we're going to do is take 2x plus 2 and make that, excuse me, greater than or equal to 0. If you solve that, you'll see that x is greater than or equal to 1. So that is like, those are my parameters. Like I can't even try anything less than or equal to 1. My x has to be greater than or equal to 1 in order for this to even exist. So then, once we know this, let's just hold that information to the side and continue solving it just as if it were an equation. Square both sides. So 2x plus 2 greater than or equal to 16. And subtract 2 from both sides, divide by 2, and you should end up with x is greater than or equal to 7. All right, check that out. All right, so our answer to our inequality is x is greater than or equal to 7. Well, that's okay. We can keep our answer then because it satisfies the x must be greater than 1. So if I use this answer, I don't have to worry about it not working. All right? And you still want to check your work. You can check that one. Here's one more for you to try. 1 plus square root 7x minus 3 greater than 3. Try that on your own and bring your completed notes in tomorrow. I'm a minute and 14 seconds over. Bye.